Assalamu alaikum. Hello everyone and welcome back to our fourth lesson in which we will cover chemical equations and alkaline earth metals. So we start with chemical equations. What is a chemical equation? A chemical equation is a symbolic representation of chemical reactions. It is the chemical equation that enables us to determine the reactants and the products, the reactants that are reacting and the product that is formed. So, for you to write appropriate chemical equations, you must remember the following. A metal reacts with an acid. Let's say sodium reacts with hydrochloric acid to form salt and hydrogen gas. What is a salt? A salt is a compound form. So, if sodium reacts with HCl, it will form sodium chloride and hydrogen gas. The second one, metal plus steam. In our previous lesson, we saw how lithium reacts with steam to form lithium oxide and hydrogen gas. So the same here, metal plus steam forms metal oxide plus hydrogen gas. The metal in the product is the metal that is reacting. In the third one, acid plus carbonate. We saw previously that there are carbonates, hydrogen carbonates, sulfates, etc. So a carbonate or a hydrogen carbonate, when it reacts with an acid, it forms a salt, a carbon dioxide, and water. The salt is the metal and the salt of the acid. Metal plus water forms metal hydroxide plus hydrogen. For example, sodium plus water forms sodium hydroxide plus hydrogen gas. Metal oxide plus water forms metal hydroxide. Now mind this, metal plus water forms metal hydroxide and hydrogen. However, a metal oxide plus water only forms a metal hydroxide. Metal plus oxygen is metal oxide, metal plus chlorine is metal chloride, and metal plus nitrogen is metal nitrate. For example, sodium plus oxygen is sodium oxide, sodium plus chlorine is sodium chloride, and sodium plus nitrogen is sodium nitride. Now, why have I written these gases? You can write down this for remembering and writing appropriate chemical equations. Why have I written chlorine as Cl2, as oxygen as O2, nitrogen as N2, uh, hydrogen as H2? Why have I written these gases like this? This is because these gases are called diatomic and they exist as atoms of 2. They are called diatomic gases. Now the information that we just wrote over here of chemical equations is what will help us determine chemical equations. So, for example, magnesium reacts with hydrochloric acid. Magnesium, and we wrote the common acids, formulae of common acids. So HCl is HClAq. To form metal plus acid is metal salt plus hydrogen gas, and the salt is the metal and the chlorine, because hydrogen is displaced. So magnesium will react with chlorine from HCl to form magnesium chloride. This will form magnesium chloride plus hydrogen gas. This is without balancing. Another chemical equation is sodium oxide plus water. Sodium oxide plus water to form sodium hydroxide. However, if this was sodium alone, to reacting with water, it would have formed sodium hydroxide plus hydrogen gas. Another example is calcium plus nitrogen. Calcium Ca plus nitrogen N2. Mind you, these gases are written as N2, O2, Cl2, F2 because they are diatomic. Calcium plus nitrogen forms calcium nitride. I taught you how to write this, the formula of compound with valencies. So calcium is valency 2, Nitrogen is valency 3, so you cross 3 and you cross 2, this will form calcium 3 and nitrogen 2. This is calcium nitride. Reacting magnesium and steam. Magnesium and steam. Now I won't be writing the words, I'll just be writing direct formula. Magnesium Mg plus steam H2O to form metal plus steam is metal oxide plus hydrogen gas. So metal oxide, metal is Mg, oxygen, metal oxide plus hydrogen gas. Another example is reacting calcium reacts with hydrochloric acid. Calcium reacts with hydrochloric acid to form metal plus acid to form salt plus hydrogen gas. So metal reacts with acid to form the salt will be calcium and the chloride as hydrogen is displaced. So this will be calcium chloride plus hydrogen gas. Another example is reacting zinc carbonate and sulfuric acid. Now I will write this zinc carbonate and sulfuric acid. We saw sulfuric acid is written as H2SO4. So zinc carbonate is ZnCO3. We saw carbonate is a radical with valency 2 and zinc is a transition metal with valency 2. So the 2 and 2 cancel to form zinc carbonate ZnCO3. Zinc carbonate reacts with H2SO4 to form. Now what did we say? We say a carbonate reacts with an acid to form a salt, carbon dioxide and water. The carbon dioxide is formed due to this carbonate and the water is formed due to the 2 hydrogen atoms and 1 oxygen which is left for the carbonate. Now zinc carbonate plus H2SO4 forms zinc sulfate, metal, salt. Salt takes the metal and the sulfate without the hydrogen. The hydrogen is replaced. We learned what is an acid. An acid is a substance that contains replaceable hydrogen ions. So in the reaction, the hydrogen ions are replaced. Zinc carbonate plus H2SO4 forms zinc sulfate plus CO2 plus H2O, which is water. Another example is reacting copper with hydrogen gas, with oxygen gas. Copper reacts with oxygen gas to form copper 2 oxide. I hope we are getting it. This is how chemical equations are written without words. The symbols are the ones that represent the words. Balancing chemical equations. Now this is the main part and I need you to focus here. Balancing chemical equations. Balancing. Chemical equations. The number of atoms reacting on the left hand side and the number of atoms in the product formed should be the same. The number of, we saw a chemical equation, let's say x plus y to form x2y. This is an example. So in chemistry, the chemical equation must be balanced. In biology, it is not a must. But in chemistry, whether you are asked or you aren't asked by the question, when you are told to write a chemical equation, that equation must be balanced. So on the left hand side, the atoms reacting on the left hand side, the number and the number of atoms formed on the right hand side should be the same. So x here is 1, but x here is 2. So how will you balance this chemical equation? You have one y atom, one y atom, one x atom, two x atom. The x atom and the y and the x atom on the left hand side are not equal. So what will you do? You will put a 2 in front of the x. So this shows you that 2 atoms of x react with 1 atom of y to form 2 atoms of x and y combined. Another example is, now we go into real examples. We say sodium reacts with oxygen to form sodium oxide. We know how sodium oxide is written because oxygen is valency 2 or sodium valency 1. So when you cross 2 here, becomes sodium oxide. So you can see here that how many atoms of sodium have reacted. Now these are called the reactants. These are called the reactants. And this is the product. How many atoms of sodium are reacting? Only one. So we have one atom of sodium. How many of oxygen? We have two atoms. How many of sodium are formed? Two atoms of sodium are formed. But how many of oxygen are formed? How many atoms of oxygen are formed? One atom of oxygen. So how do you balance this? You must make sure that sodium atoms reacting and sodium atoms formed should be the same, and oxygen atoms reacting and oxygen atoms formed should be the same. What will you do here? You will place a 2 on the sodium to balance the 2 of the sodium here. However, here there is one oxygen and here there are two oxygen. How do you balance this oxygen to balance this oxygen? You put 2 over here. You put 2 in front of the whole compound. Now this shows you that there are 2 atoms of oxygen. However, how many atoms of there are of sodium now? Because this 2 applies to the whole compound. So 2 times 2. Now there are 4 sodium atoms. So you will remove this 2 over here and put 4. Now your equation is chemically balanced. Why? Because there are 4 sodium atoms, and here if you place a 2 and there are already 2 sodium atoms, 2 times 2 is 4. So there are 4 balancing 4. There are 2 oxygen atoms. This 2 also applies for this oxygen. So 2 oxygen atoms, and your equation is chemically balanced. Another example. Copper plus oxygen. Copper plus oxygen to form copper 2 oxide. This equation is not chemically balanced. Why? The number of atoms reacting of copper are 1. The number of oxygen atoms are 2. The number of copper atoms formed is 1. But however, the number of oxygen atoms also 1. So you need to balance this oxygen with this one. So you will place a 2 in front of the whole compound. Now this tells you that there are 2 copper atoms and 2 oxygen atoms. And now since there are 2 copper atoms and here there is 1, here now there are 2 and here now there are 2. Here there are still 2, but of copper there is only 1 remaining, so you put a 2 over here. Now this equation is chemically balanced because 2 copper atoms plus 2 oxygen atoms to form 2 copper atoms and 2 oxygen atoms. Another example is sodium plus water. Sodium plus water to form sodium hydroxide plus hydrogen gas. Now in our previous examples there was only one product. Here we have 2 products, so both the hydrogen atoms here and here will be combined. Then how many sodium atoms are there? 1. How many hydrogen are reacting? 2. How many oxygen are reacting? 1. How many sodium atoms are formed? 1. How many oxygen? 1. And how many hydrogen are? 3. These hydrogen are 3. So what do you have to balance? Your sodium atoms have been balanced. Your hydrogen are not balanced because here reacting are 2 and product is 3. Your oxygen is 1 and 1, so your oxygen is also balanced. So what do you have to balance? You have to balance your hydrogen atoms. How will you do this? On the product side there are 3 hydrogen atoms, but on the reactant side there are 2. So you will put 2 in front of the water to form 4 hydrogen atoms and 2 in front of the sodium hydroxide to form 2 hydrogen atoms, and now this shows you that there are 2 sodium, so you also put a 2. Are you getting me? Let's do this again. How many atoms of sodium are reacting? 1. How many of hydrogen? 2. How many of oxygen? 1. How many of sodium? 1. Oxygen 1 and hydrogen 3. What do you have to balance here? The sodium and sodium are balanced. The oxygen and oxygen are balanced. But the hydrogen are 2 and the hydrogen here are 3. So you have to balance this 2 hydrogen with this 3 hydrogen. Now you can see here it is an odd number of hydrogen atoms, 1. So you have to make this odd number even. You put a 2 over here. How many hydrogen atoms are there now? 2 hydrogen atoms and this 2 for these 2 hydrogen atoms. So these are 4 hydrogen atoms. So from 3 this has changed to 4. How many hydrogen atoms are here? 2. So how do you make them 4? By putting a 2 in front of the oxygen, the water. As you put 2 in front of the sodium hydroxide, this also now means that there are 2 atoms of sodium. So here also, here now there are 2 atoms of sodium, but here there is 1 atom. So you will also put a 2. Now this equation is chemically balanced. I won't be writing everything, but you can listen as I read the question. Magnesium reacts with hydrochloric acid. Write the chemical equation. Magnesium reacts with hydrochloric acid. Write the chemical equation. So when an acid reacts with a metal, it forms a salt and hydrogen. The salt is magnesium, which displaces hydrogen to react with chlorine. So this magnesium chloride plus hydrogen. Where did I get magnesium chloride from? Magnesium being valency 2, chlorine being valency 1. When you cross the 2, chlorine gets the 2, so magnesium chloride. How do you balance this? How many atoms of magnesium are reacting? 1. How many of hydrogen? 1. How many of chlorine? 1. However, how many have been formed? 1 of magnesium, 2 of chlorine and 2 of hydrogen. So you have to balance the chlorine with the chlorine and the hydrogen with the hydrogen. There are 2 atoms of hydrogen and 2 atoms of chlorine. And here there is 1 and 1, so you put a 2 here. This tells you that there are 2 atoms of hydrogen and this 2 also applies for chlorine and there are 2 atoms of chlorine. Now this equation is chemically balanced. Magnesium 1, magnesium 1. Chlorine 2, chlorine 2. Hydrogen 2, hydrogen 2. Reaction, the last example is reaction of sodium carbonate and nitric acid. Sodium carbonate written as Na2CO3 plus HNO3 to form sodium nitrate plus CO2 plus water. Sodium carbonate reacts with HNO3 nitric 5 acid to form sodium nitrate. The salt is, we say, the metal, and the metal replaces the hydrogen ion, form sodium nitrate. Sodium valency 1, nitrate valency 1, so it directly exchanges to form sodium nitrate, and it is a carbonate, so it produces carbon dioxide and water. How do you balance this chemical equation? How many atoms of sodium are there? There are 2 atoms of, we have 2 atoms of sodium over here. How many of carbon do we have? 1. How many of oxygen? 3. How many of hydrogen? 1. How many of nitrogen? 1. And how many of oxygen? 3. How many sodium have been formed? 1. How many nitrogen? 1. How many oxygen? 3. How many carbon? 1, oxygen 2, hydrogen 2 and oxygen 1. So if you add, there are 6 oxygen. Oxygen are 6 on the reactant side. Sodium are 2. Carbon is 1, nitrogen 1, hydrogen 1. If you add here, oxygen are 7 on this side. Oxygen are 7 and hydrogen are 2. Carbon is 1. So carbon is balanced, oxygen is not balanced. No, oxygen is also 6. 3, 4, 5, 6. So what is not balanced in this chemical equation? What is not balanced is sodium carbonate. Sodium and sodium. There are 2 atoms here and 2 atoms here. So you have 1 atom here. So you will put a 2 here to form 2 atoms of sodium. Now the nitrate is automatically taken. This 2 automatically applies to the whole nitrate now. So there is also a nitrate here, so you will put 2. How many, what does it affect now? How many hydrogen are there? There are 2 hydrogen and there are 2 hydrogen. How many oxygen are there? 6 and 9. How many oxygen are here? 6, 7, 8, 9. So your equation is chemically balanced. 2 atoms of sodium, so I kept a 2 here for this one atom of sodium to form 2, and now this made it to form 2 nitrates, so we balanced 2 nitrates and 2 hydrogens, balance 2 hydrogens over there. So this is what balancing chemical equations is all about. The atoms on the reactants and the products should be of the same number, and when you balance one atom with another, if it affects any other, you must continue balancing until all the atoms on the reactant side and on the product side are completely balanced. Now our next subtopic where we should have started in this lesson is alkaline earth metals from the previous lesson. Alkaline earth metals. Now the good part is that alkaline earth metals have similar properties as alkali metals. They have the same trends. Alkaline earth metals. These are group 2 elements. We have beryllium, we have magnesium, and there is our good friend called calcium. So beryllium is 2, magnesium is 2H2, and potassium is 2,8,8,2. What does this tell you? There are 2 electrons in the outermost energy level for beryllium, magnesium and calcium. We dive straight into the properties. Atomic radius. Atomic radius increases down the group due to an increase in number of energy levels. What we have already discussed, I will not ponder on that. Atomic radius increases down the group due to an increase in number of energy levels. Ionic radius is the same. Ionic radius increases down the group also due to an increase in number of energy levels. But I have to stress on this. The ionic radius is greater than the atomic. The ionic radius is smaller than the atomic radius. Ionic radius is smaller than the atomic radius. Since the valency electrons are lost and hence the energy level is lost. So a magnesium ion has less energy levels than a magnesium atom. Hence it has a smaller atomic radius. Reactivity also, as we saw in alkali metals, reactivity also increases down the group. Due to an increase in number of energy levels, hence weaker nuclear force of attraction, the valence electrons can be easily lost. The explanation is the same. However, if you compare the reactivity of alkaline earth metals with alkali metals, alkaline earth metals are less reactive than alkali metals. Why? Because alkaline earth metals have more protons than alkali metals, hence a stronger nuclear force of attraction. So if you compare down the group, alkaline earth metals have the same trend in reactivity, it increases down the group. But if you compare alkaline earth metals with alkali metals, alkaline earth metals have more protons, hence a stronger nuclear force of attraction. The valence electron is not easily lost compared to the alkali metals. Reducing property also. Another is reducing property. This is the property of the metals which lose electrons, readily lose electrons. So it also increases down the group. Explanation is the same. Reducing property of alkaline earth metals increases down the group. This is because due to an increase in number of energy levels, hence weaker nuclear force of attraction, the valence electrons or the outermost electrons are easily lost. So calcium is more reducing than magnesium. Why? Because it has 4 energy levels. Magnesium has 3 energy levels. So calcium has a weaker nuclear force of attraction than magnesium. Hence, it loses its electrons more readily. Electropositivity is the same. It also increases down the group. Electropositivity also increases down the group due to the same with the same explanation as in alkali metals. Ionization energy. Ionization energy decreases down the group since less energy is required to lose the valence electrons. However, alkali metals have only one ionization energy because they have to lose only one electron to gain octet stability. However, in alkaline earth metals, they have two ionization energy. We have the first ionization energy, and the second ionization energy. Now, the first ionization energy is less than the second ionization energy, or the second ionization energy is more than the first ionization energy. Why? This is what you have to know. The second ionization energy is more than the first ionization. Why is it so? This is because magnesium having, let's take the example, magnesium having 282, it loses one electron at a time. So when it loses its first electron, it becomes 281. However, the number of protons still remain the same. So what is that bringing me to? That brings me to that the protons become more than the electrons, hence a stronger nuclear force of attraction. Now, when there is a stronger nuclear force of attraction, the valence electron is not easily lost, hence it requires more energy. We explain again. Magnesium having 282 loses its first electron to form 281. Now this 281 is not yet stable. It has to become 28 to gain octet stability. So it also has to lose this one electron. But it requires more energy to lose this one electron, because when it already lost the first electron, the protons became more than the electrons, hence there is a stronger nuclear force of attraction. Take my words, I am not writing this. The second ionization energy is greater than the first ionization energy. Why? Because on losing the first electron, the protons become more than the electrons, hence there is a stronger nuclear force of attraction. Full stop. We have melting and boiling points. Melting and boiling points also increases down the group. Same explanation as alkali metals, also increases down the group. So calcium, melting and boiling point decreases down the group. Sorry for that. Melting and boiling point decreases down the group due to an increase in number of energy levels, hence decrease in due to an increase in atomic radius, hence weaker nuclear force of attraction. However, the melting points of alkaline earth metals corresponding to their alkali metals. Let's take the example of sodium, which is an alkali metal, and magnesium, which is an alkaline earth metal. The melting point of magnesium is higher than the melting point of sodium. Why? Magnesium having 282 and sodium having 281. Magnesium has more electrons, has more delocalized electrons, hence a stronger metallic bond than sodium. We go to physical properties. Now physical properties is where it changes from alkaline metals to alkaline earth metals, that the properties change. We said alkali metals. We said alkali metals are soft metals and they can be cut with a scalpel. However, alkaline earth metals are relatively hard. They are good conductors of electricity, as the same as alkali metals, due to presence of delocalized electrons of electricity, due to presence of delocalized electrons. Some are malleable, some are malleable. Now what is a malleable metal? A malleable metal is one which can be made into thin sheets. Malleability is the ability of a substance to be hammered into thin sheets, e.g. magnesium. Now I won't be writing everything, but malleable, some are malleable. Malleable is the ability of a metal to be hammered into thin sheets for use. So the example of malleable is magnesium, while others are ductile. Ductile is the ability of a metal to be hammered into wires, or to be made into wires, to be drawn into wires, e.g. also magnesium. However, some alkaline metals are brittle and can easily be broken. So you can be asked in your exam difference between malleability and ductibility. Malleability is the ability of a metal to be hammered into thin sheets, while ductibility is the ability of a metal to be drawn into thin wires. Chemical properties. It's the same because a metal reacts with water, so reaction with water is the same as alkali metals. Form, let's say magnesium plus water forms magnesium hydroxide plus hydrogen gas. Why is this OH in 2? Because magnesium is valency 2. Observation, effervescence is observed. However, this reaction is very slow. But for us to see a visible reaction, we use calcium, which is more reactive than magnesium. So we can use calcium instead of magnesium with water to form calcium hydroxide and hydrogen gas. What is the observation in this reaction? The observation in this reaction is a white precipitate is formed. A white precipitate formed. And second, there is effervescence. Effervescence in short means bubbles, but in chemistry we use the term effervescence of a colorless gas. Why is there effervescence of a colorless gas? Due to production of hydrogen gas. Why is there a white precipitate formed? Because calcium hydroxide is slightly soluble. It is slightly soluble but almost insoluble. So hence, if a substance completely dissolves, it dissolves to form a colorless solution. However, if a substance is slightly soluble or insoluble in water, it forms a white precipitate. The resultant solution is a weak base because calcium hydroxide is slightly soluble, hence partially ionizes to give less hydroxide ions. It has a pH of 10. So calcium hydroxide has a pH of 10. It is a weak 10.0. It is a weak base. Now you don't have to learn why it is a weak base. That will be taught in Form 4, but you should know that pH 10, as you know the pH the values. It is a weak base because it ionizes to give less hydroxide ions. Reaction with air. Alkali metals react with both oxygen and nitrogen. Alkaline earth metals react with both oxygen and nitrogen in air, same as alkali metals. However, just the formula is different due to difference in valency. So magnesium reacts with air, oxygen and air, to form magnesium oxide, and magnesium also reacts with nitrogen to form magnesium nitride. We balance these equations: magnesium 1, oxygen 2, oxygen 1. So you put a 2 here for 2 oxygen. However, this has changed to magnesium and you put a 2 magnesium. Your equation is balanced. Same here. There are 3 magnesium atoms, but here there is 1, so you put 3, and there are 2 nitrogen and 2 nitrogen. So this equation is also chemically balanced. However, when water is added to the white solid, the same as we saw in alkali metals, it's completely the same. When you add magnesium oxide to water, it forms magnesium hydroxide. But if you add magnesium nitride to water, it forms magnesium hydroxide plus ammonia gas. It's the same. Reaction with steam. In alkali metals, we saw that only lithium reacts with steam. Here, because lithium is moderately reactive, but magnesium is less reactive than lithium also, so it can react with steam. Magnesium reacts with steam to form magnesium oxide plus hydrogen gas. This equation is balanced because 1 magnesium atom, 1 magnesium, 2 hydrogen, 1 oxygen, 1 oxygen. And we saw the setup in which there is a glass tube and there is we have magnesium here, we have magnesium over here, we have wet sand is heated to generate steam, it reacts with magnesium to form magnesium oxide, and hydrogen gas is collected over here. Reaction with acids. Magnesium reacts with various acids, HgHCl, to form. We saw an acid reacts with a metal to form a salt and hydrogen gas. The salt consists of the metal and which displaces the hydrogen. So magnesium chloride is the salt. However, magnesium chloride is written as MgCl2 because magnesium being valency 2, chlorine being valency 1. When you cross the 2, magnesium becomes magnesium chloride with a 2 on chlorine plus hydrogen gas. How do you balance this equation? We have 2 chlorine atoms, so we have put 2 over here, and the whole equation is balanced because 2 hydrogen, 2 chlorine, 2 chlorine, 1 magnesium, 1 magnesium. Magnesium also reacts with H2SO4, sulfuric acid, to form magnesium displaces hydrogen to form magnesium sulfate plus hydrogen gas. How do you balance this equation? Magnesium is 1, magnesium 1, hydrogen 2, sulfate 1, sulfate 1. This equation is also chemically balanced. Reaction with chlorine gas. Now instead of magnesium, you can have calcium as the same, or even beryllium. So reaction with chlorine gas, we saw as alkali metals react, alkaline earth metals react in the same way. Magnesium, let's use calcium. calcium reacts with chlorine to form calcium chloride. This equation is balanced. Why is this written as Cl2? Because chlorine gas is diatomic. We come to the end of the our subtopic alkaline earth metals, which is uses of alkaline earth metals. Of alkaline earth metals. I won't write them. I will just read them for you, and you can write them. So calcium carbonate is used to manufacture cement. Calcium carbonate is used to manufacture cement. We have an alloy of magnesium, copper and aluminium is used to make aircraft bodies. An alloy of magnesium, aluminium and copper is used to make aircraft. You only need to know two uses maximum. Magnesium hydroxide is used to make antacids. Since it is an insoluble base. This is one main use of alkaline earth metals, the ferron. Magnesium hydroxide is used to make antacids since it is an insoluble base. Let's say that we have a bee sting. The question of bee sting, you may have seen it in Form 1. When a bee stings you, you feel acid irritation or you get irritation due to an acid. What do you take? Magnesium hydroxide. Since it makes antacids, it is an insoluble base. It neutralizes acids. That brings us to the end of alkaline earth metals. We will now look at halogens and noble gases, and then we will be done with our topic chemical families. So just to make sure, alkaline earth metals properties and reactivity is the trend is the same as alkali metals. So we will see each other in the next lesson. Until then, goodbye, take care, thank you for watching, have a good night.